Okay, mag-start ta, no? So, kanang this lecture class is a continuation of what we've discussed last meeting, no? Not yesterday, no? So, we've discussed about capacitor, and we know that capacitor is a device, no? Or passive device, no? Or, yes, electronic device that act as a filter, no? So, it will block DC and eventually pass DC. That's why you find out capacitor uh, in a lot of power supply, no? So a series of resistor, capacitor, inductor, and diode in power supply circuits or circuits, no? So uh, we discuss a lot, no, in our in our series parallel, a lot of theories and Kirchhoff's law analysis, basic circuit analysis on resistor. We know that resistor, uh, the characteristics of resistor in a series parallel connection. Here also is we will focus more on series parallel connection of a capacitor. What is its characteristics? Would it the same as resistor? Okay, so we'll discuss it here, no? So uh, the application of, for example, no, as a prelude to our discussion, okay, we have some capacitor banks for energy storage, no? Because aside from filtering or blocking DC, passing AC, capacitor also act as a energy storage, no? Okay, so most supercapacitor cells are rated in range of 2.5 volts to 3.3 volts at a room temperature, no? So if you are going if you are into designing, this is the range of voltages, no? When you design supercapacitor banks, no? Typically the target voltage should set below the maximum rated voltage to extend the operating life of the supercharged capacitor or supercapacitor. So if you exceed in 3.3, okay, so basically capacitor life shorten, no? So there are instances that it will blow ups or bloated, maborot ang mga capacitor. By the way, class, when you do some circuit experiment at home or at work in the future, no? So there's a technique on how to discharge capacitor, no? So i-short lang na nimo ang iyahang duha ka terminal using a resistor or load bank or imong i-short sa ground. Okay? So mo nay pag-discharge og capacitor, no? Because we know capacitor is also an energy storage. Okay? So mo ito timan-an, no? If you are designing a supercapacitor banks, the voltage should be 2.5 volts to 3.3 volts. If you ask me how this range of voltage arrive or yun sa pag-determine, no? These are determined on laboratory experiments, no? Based on our source, no? Because we get this lecture also from books or sources from the internet, no? So when we have this capacitor, for example, no, if because we cannot increase, no, the voltages of capacitor. Let's say we want to maximize our super capacitor. So what we're going to do is we do series arranged capacitor. No, like in this presentation, we have these three capacitors connected in series. By the way, class, madungog pa ko ninyo. Klaro ra akong tingog. Can I hear confirmation from you?
Yes, sir.
Okay, kay basig nagtabi na kung taman dire tapos wala mo kadungog. So this is the arrangement, no. Let's say we in a microprocessor, because microprocessor which is found in many computers, the minimum voltage of microprocessor is 5 volts, no? Because as we know, there are range of voltages in a power supply. For example, if we have PC, no? So not a power supply, if you look at PC, if you happens to dismantle PC in the future or during your senior high school years, no? There's a lot of voltage type 5.5, 99 volts, 912 volts, 924 volts, no? So in microprocessor, the minimum voltage of microprocessor is 5 volts, no? And then how we are going to arrange a supercharged capacitor in a microprocessor, because as we know, microprocessor class is an integrated circuits, no, na yung mga capacitor diha, inductor, and many other types of uh, electronic devices, okay, arranged in an IC type or surface mount ICs, or in this case we have the microprocessor, no. So ato na siya i-series, no, to maximize the output or the performance of microprocessor. So put capacitor in series to obtain higher voltage, no, because as we know, the range of capacitor is only up to 3.3, no, 3.3 from 2.5. Okay, so I hope uh, it's clear, no. So in a capacitor di ay sa ato ang mga electronic devices, since we have this range only, kanilang ato nga mga range class, so what we do is gi-series na nato, no, to attain maximum voltage, no. Okay, no. So that's it, no. So in a parallel capacitor class, so as we know, no, this the capacitor has this what we call this one, has this capacitance, no. So capacitance, the unit of capacitance is farad, and sometimes expressed in microfarad, picofarad, or farad, no, or microfarad, no, depending on the amount or the capacity of the capacitor in farad, no. So as we know, to compute for farad, no, we have an exercise for this. I guess last last time is that the permittivity, no, represented by uh, epsilon, no. This is inherent to materials, no. So on the materials we use in the capacitor, and then we have this area. So we multiply that permittivity of the material used in a capacitor and the area. This is the plate, no. So in this case, we're using a rectangular plate, no. So if you notice, class, capacitors are round, no. But for example, no, you wonder why we're discussing capacitor in a rectangular, no, but in actual capacitors are no, are constructed round. So what the manufacturers did is this plate, no, rectangular, is wrap around, no. So that's why capacitors in the market, you see that one kuan siya, no, kanang ano siya tawag ani, not round but cylindrical, no. The base area is round. Okay, and then we have distance, no. The distance is, this is the milli distance, no, kanang dikit yung guys ang distance, no, but not touching, no, it's plate. Okay, so what happened then if there's what we call parallel capacitor, no. So the next slide would tell, no. Okay, so for example, here we have a parallel capacitor, no, same with the arrangement on the parallel circuit. So let's say we have an identical capacitor arranged in parallel. What happens is that it's just the same as connecting capacitor, ano, connecting capacitor together, no. So what happens is that the everything in the capacitor, particular not everything, by the way, particularly area, okay, this area, class, this area will double, no, di ba? If you look at, we have capacitors, this area is double, the d is the same, no, this is the distance, no, the same, and of course, no, the permittivity, because we're using the same material, is the same or constant. So basically, in our analysis of what we call this one, parallel capacitor is just the same as we treat that as like this, no. So inano siya, no. So going back to the basic formula of capacitance, no. So we just multiply the capacitance into two if we have these two capacitor parallel together, no. So if we're going to inspect the area, so since permittivity is the same, constantly siya, class, because you're using material, and the distance of course the same because these are identical capacitors joined together. So these are mahog na to, nahog na constant in this equation. So what doubles is the area, or basically we just times two, no, multiply or double the capacitance of the first capacitor, no. So nakuha ra ninyo class, no, what I'm telling you or what I'm emphasizing in this lecture, in this no. So kung naay duha ka capacitor, what we do identical is what we did is that just like combining two capacitors into one big capacitors, okay, and the capacity is 2C or twice the capacitance of the first capacitor, okay. So we'll move to, so what happens then in identical capacitor is that the capacitance is twice of the first capacitor. But what if there are not identical capacitor connected together, no? So unsa may mahitabo, no? What would be happen? So we just add the capacitance, no? Add the capacitance in parallel capacitor class, no? So have you noticed in a resistor class when a resistor is connected in series, let's say these are series resistor, what we do is that just add the the resistor, no? Let's say this is one, this is two. So to get the resultant resistor or uh, resistance of a circuit is we just add, no. In parallel is the same concept, no. So when capacitor is connected in parallel, the assumption or the sa tawag na, the synonymous to that is when we have a resistor connected in series, okay. Remember in series class when we have two series, no, let's say this is a parallel resistor, unsa ganito yung formula ani pag 1 is 1 over R total is equal to 1 over R1 plus 1 over R2, di ba? So, yun ani man ni ang resistor, di ba? Kung parallel, yes, but in a parallel capacitor, we treat the formula as like a series resistor. So, muna itong timan-an, no? Bali siya. Okay, by the way, class, I already checked your activity exercises and midterm exam, and I've already turned in back to you, no, for you to check, no. So if you have questions, clarifications, you can message me, no. So prior making or finalizing your midterm grade, okay. So that's it, no. And then we have this formula, no, in a series class, okay, series. Since we treat parallel resistor in like a series in a we treat, by the way, we treat kumbaga, we treat parallel capacitor as a series, no, compared to resistor. Here also is bali, no. So when we have resistor connected in series, when we have what we call this one, capacitor connected in series, okay, the assumption of that or the formula for that is just like on the how we add resistor in parallel. So parallel, no. So unsa itong parallel ani? So how we're going to simplify this one is just 1 over C, okay, equals to 1 over C1, okay, C total for example, plus 1 over C2, the second capacitor, and so on, no, if there is what we call nth capacitor. So nth, no. So that is the formula of how we're going to add the capacitance of a series connected capacitor, no. So this formula translate actually this one, okay. So I guess I check if we have example later, no. Okay. And for example, no, find the effective capacitance of the combination below. So effective capacitance daw. So meaning the total capacitance, no. So this is how we're going to how we're going. So this I'm going to explain this one, no. So because this is your activity later, no. This is your activity, Okay, activity exercise after we discuss. So what you are going to do is that uh, you need to, if we're going to inspect class, no, these two microfarad and 8 microfarad are connected in series, and then the resultant of that is parallel to 3 microfarad, no, 3 microfarad. So what you are going to do is that um, you treat this one, you add this one like a parallel in series circuit, and then the two parallel, the resultant of this one is you are going to add, no, since parallel na ni siya ang resultant ani, let's say this is CT, okay, the resultant of that one of these 2 microfarad and 8 microfarad makuha na ninyo, and then you just add this one because that CT would become resultant, no, of the combination of 2 and 8 microfarad. So may tabuan ni class igunaan na siya, no. So natay kuan, okay, kanina siya, no, resultant ani, no. So by the way class, capacitor and independent power supply di mo makakuha, no. So independent power supply is dako ang usa, gamay ang usa, no. Ang capacitor tungod sila, no. Nasa mga instances nga bawog di siya, no. That is what we call polarized capacitor. So naay positive na negative. This is the positive and this is the negative. Pero at this example, dili siya polarized, pwede siya bali-balik, no. So so the resultant would be this will become 3 microfarad, okay? And this is the CT. So I guess the difficult one is on how to get the resultant of 2 microfarad and 8 microfarad. So you get the total capacitance of the circuit, no? So that would be your activity exercise later, no? So tiwason na nato, no? Tiwason na nato. Okay? Okay, no? So moving on, no? So key concept of a parallel and series connected capacitor is that parallel capacitor, this is the formula, no? So what you do is just add, no, the capacitance, no? Add the capacitance, okay? So while in series, it's the other way around. That is the inverse of the total of the capacitance. So this is the general formula. So kani siya class, kung ato na siyang i-translate into kwan, C total, okay, is equal to 1 over C, 1 over C1 plus 1 over C2 plus, okay, 1 over Cn. Cn is the end capacitor. Let's say duha siya o tulo siya upat. So here is just C total is just addition, no? C1 plus C2, yeah, plus Cn, no? Kung daghan siya ang capacitor. Okay, no, that is the last slide. Last slide na to siya class, and for the rest of the time you will do ano, you will do this activity exercise, no? Kaning activity exercise. And then by the way, I'm still online, open for consultation, no? So is there any questions, clarifications on your activity exercise? None so far?
Sir, excuse me, sir. For example,
Sir,
og kanang
ano,
naa na
sige
dyan mga
sir.
value, sir.
Hello?
Hello, sir.
Well,
Ni.
yes?
Sir, pwede ka mag-example ka ng naa na dyan value nga katong mga yung formula, sir ba?
Sige,
Example.
example ta, no? Example ta.
Yes.
So, siguro atol ni example, no? Atol ni siya yung example, no? Kani siguro. Para makasabtan ninyo. Kani, no? Kani. Okay. Sige, example na to ni ha. Aha. Kita ninyo class, no? Nakita niyo yung example na to? Hello? Maklaro
Yes,
ra ang akong
sir.
share screen?
Yes,
Sige.
sir.
Sige. So, for example, no, as I mentioned kanina or as I discussed, no. Dali lang ha. Unsa ba ni siya, no? So, kaning duha ka capacitor, kaning duha ka capacitor class, ato siyang computo na to resultant ani, no. Okay? Computo na to siya. Computo na to siya, no. Kani. So, unsa ito yung formula ni? 1 over C T is equal to 1 over C1 is 2. Dili na to isulat ang micro, no, kay lisod na kaya sa akong ano nya 1 over 8. 1 over 8. Sa ito yung formula ni sa CT. Sa nga ito ni pag treat. Sa ito yung formula ni. Di ba na may kuan ni for 2 capacitor? Sa nga ito ni. Nakalimot na mo. Nakalimot na mo katong C T. C mas parallel ba? Katong R ba? R total is equal to R1 times R2. Di ba? Over R1 plus R2. Di ba? So in this case, where since this is a capacitor, will not ano? Nakalimot gid mo, no? C1 C1 ay sorry. C1 C2 over R1 C1 plus C2. Nakalimot na mo, di ba? So this is the formula, right? Anyone remember? Okay, by the way, no, 3 minutes break, no? Kuha lang ko calcio, no? Magkuha lang ko calcio class, no? 3 minutes break, magkuha lang ko calcio, no? Okay, no? So, okay na ta, no? So, unsa man nato ni, no? This is 2. 2 times 8 Okay, 8. And then over 2 plus 8 is 10. Diba? This is equal to 2.6. The unit is microfarad. Nakanindot lang siya class is the same lang microfarad. No? What if this is millifarad, this is microfarad, and this is picofarad. So that is the difficult one, no? Because you are considering the scientific notation of the unit, no? So mo na lisod, okay? So timanin yun 2 microfarad. Okay, so the resultant would be like this one, no? So we have this one. Okay, this is the capacitor 1. So pila man 3 microfarad. And then series 2. The resultant of 2 and 8 connected in series is 2.6, di ba? 2.6 microfarad, okay? So, saan man So, nanatay parallel. Unsa ito parallel? Just add the two capacitor. So, C in parallel, C total, okay? Total in the circuit class is actually equal to 3 microfarad plus 2.6 microfarad. So, what is the answer? 3 plus 2.6.
Excuse me, sir.
Bali, dili na sa 2.6, 1.6
Ano,
din nino.
2.6 tiya, sir? 1.6 man.
1.6 nino.
Yes, sir.
1.6 no. Sorry no. 1.6 and this is 1.6 no. So thank you for that correction no. This is 1.6. Okay. (1.6) ni siya no. So this is also 1.6 no. 1.6. Okay, 1 point basta 1 ni siya, 1.6. So 3 plus 1.6 that is 4.6 microfarad. Yeah. So this is the answer, no? This is the answer. This is the answer to this question. No? Find the effective value capacitance. So effective capacitance, the total capacitance, no, of the combination below. So nakuha ninyo questions, clarification, or example? Sige daw. Tanaw daw, nambay mga questions,
Sir,
clarification.
how about kung tulo siya ka buo? I-same ra gyapon na C1 times C2 times C3.
Kani, what if the question is what if, for example, na capacitor dilain, let's say 1 microfarad. Dili na siya mo apply, no? Because this formula intended for
Luhara.
two capacitors in
Okay.
parallel, no? So unsa man ito formula? The same as series, no? Mag-erase ko ha. Anyway, this is recorded man class. No need to copy, no? Unsa kay ito formula when multi resistor in series katong previous na kong klase? Kanina ang formula ha, 1 over C total is equal to 1 over C1 plus 1 over C2 plus 1 over C3 and so on, no? And 1 over Cn, no? So and C. So actually you can still try, no? Try ninyo ni class. Using this general formula i-try ninyo ni. Using that general formula ba? Try this one ha, Ato ni apply ha. 1 over C total 1 over C total is equal to 1 over 2 plus 1 over 8.
8.
Di ba mo arrive yung talyapon og 1.6. Try daw ninyo. Sige daw, try. Try ninyo.
Yes.
Sige, try ninyo. Using this formula. Sige, try ninyo. So kung na mo yung calculator class, no? Hindi lang ha. Okay. Kailangan. So kung na mo yung calculator, i-open na akong camera. Okay. Okay, no? Sige, kung na mo yung calculator, no? Calculator, no? So, ako I'm using scientific calculator, no? So, for example, no? Pila man ito? 2. So, pindutan kog 2. Inverse. Inverse siya class. Plus 2, plus 8. Inverse, equals, no? Whatever is the sum of that is, ako pag siyang inverse because that is 1 over C1, di ba? 1 over C total, di ba? Inverse. So, what is the answer? That is 1.6. Marag di maklaro, no? Dahil lang. So, inanin yung buhato, no? So, kung na mo yung calculator at home, ato ning i-erase siguro. Na mo yung mga calculator sa inyong cellphone. So, makakita mo value, no? Value sa inyong kita mo sa inyong calculator, scientific calculator, x, tapos na ay exponent negative 1. Actually, ang equal ani is equal na siya 1 over x class, no? Diba? Using a fraction, diba? Itong fraction na itong rule ba? Equal na silang duha, no? Kani. So, kani nanis yung calculator. X to the negative 1. So, going back to the formula, diba? 1 over,
over extra.
1 over total man ta, no? Equals to 1 over C1, di ba? C1 or 2 plus 1 over 8, no? So, unsaon nyo pag 1 na? So, inyong buhaton is 2. Type mo to sa inyong calculator and then pinduton ninyo ang x to the negative 1, no? X to the negative 1. Negative 1. Yeah. Plus na pod. Type nyo 8. Type mo 8. Okay. And then in your calculator, naamoy katugya pong x to the negative 1. So, equals. Pila may equals ana? So, equals na result, no? Na result, no? Okay. Result na result. Kanang result, inyo na din siyang, whatever the result, inyo gyapon na siyang for example, using the operation 2 inverse plus 8 inverse equals, so that the total for this one is 0.625. So what in this operation class, kaning operation, what you're performing is this one. Kani lang siyang operation. Napa may 1 over C total. So, inyo sa ni siyang inverse. So, pindot mo sa inyong calculator, katong x to the negative 1. Kani nga symbol ba? X to the negative 1 ba? So, you arrive at 1.6. Okay, that is the... So, to check that one, you can check that one on the formula sa duha ra ka kapasitor katong C1 times C2 all over C1 plus C2. You arrive of the same answer 1.6. Okay? Same answer 1.6. Sige. Okay. So, yun ana siya ang kuan. Kaysa binagsahon ninyo ni 1 over 2, 1 half. Yeah. Pwede sa nato ni binagsahon. Tanaw na to. Saan nato ni pag kuan. Pwede sa nato ni katong operation nato bitaw nga kuan, no? What is ato ni siyang simplify ba? Say this is 1 over this one, no? The 1 over C total, di ba? So 1 half is 0.5, di ba? Plus, di ba? Plus 1 over 8, pila ng 1 over 8? 1 over 8 is 0.625. 0.125, di ba? So, ato
Sir,
na siya in
1 to
total. So, plus 0.5, pila man na siya? 0.625. So, pero 1 over C ni siya, di ba? 1 over C total, di ba? So, ang ito na pagpagawas ang, so, so, ito ni pagpagawas ng 1C total, may mong numerator, di ba? I-times na to ni dito, move na to ni siya. Kuha ninyo, move.
Yeah.
So, mahog na ni siya nga 1 equals to 0.625 CT, di ba? So, CT. So, unsa man nato ni nga CT nila mabilin diri. So, ang resultant ani is CT kaning 0.25 balin to spekas the other side of the equation. May mo siyang denominator, di ba? So, 1 over 0.625 and 1.0625 is equal to 1.6, di ba?
1.6.
So inana ang binagsa. But what if we have a lot of capacitor, mini capacitor, and then amoy calculator. So it is advisable to practice this technique, no, using a calculator. Kaya mga calculator karon plus app naman sa cellphone, di ba? Nakuha ninyo?
Yes, sir.
Okay, so is there any questions how we arrive the 1.6 using the traditional way, using the simplified formula, and using the general formula? Kani siya, general formula ni siya. General formula ni siya. General formula. Yeah, traditional katong ato yung use sa usa, using the general formula and using a calculator kani siya. You can try at home siguro, no? Sige. So, di na lang ko mag-activity exercise, but we move to another topic, which is the inductor. No? I believe yesterday you have watched a video, no? Because I am not available for synchronous class. So we do instead asynchronous by watching a YouTube video on the concepts of capacitor. No? So, okay, asan man to akong capacitor? Inductor. Okay, so inductor. No? So inductor, capacitor. So this is inductor. No? So inductor, what is inductor again? Inductor, okay, so in our discussions of inductor, we understand the relationship between current and voltage of the inductor. And then an inductor is a passive device, no? Capacitor also is a passive device. Inductor also is a passive device that store energy in its magnetic field and return energy to circuit whenever required. Okay, sa capacitor, ni-store siya og energy to its plate. Ang inductor, store energy to its magnetic field, no? So kani, no? Key concept, no? Magnetic field and returns energy whenever required. An inductor is formed by cylindrical core. This is the cylindrical core class. And then turns of conducting wire. Okay, so this is the turns of conducting wire. So this is your current. Okay, current flow on that inductor. So if you notice, no, katong mga electromagnet inyong gi-perform in the physics days during high school. So that is example of an inductor class, no? So there's what we call EMF here. The EMF is that is the voltage, no? That translate to electromagnetic field. Okay. So the symbol of inductor is this one, no? So wound wire. Okay, that is an inductor. Okay, so next slide. So in an inductor, when there is a flow of current, kita mo ni there's what we call flow of current, no? So kani ang flow of current niya, flow of current, no? So in this slide, okay, so the flow of current na ay ginatawag og magnetic field along, no? Along the core. So this magnetic field is a force, no? Vector na siya, no? So vector, no? So this is a vector force. So this magnetic field sometimes act as an electromagnet, no? Okay? And so the unit of inductor class is is inductance, no? Capacitor is farad, ang inductance or inductor, capacitor, capacitance ang kuan niya, ang capability. So sa inductor, inductance, but the unit is Henry, no? Henry, no? So we have this formula, no? Henry, no? So to determine the inductance with the unit Henry, that is represented by letter L, okay? Not letter H, but letter L, or not letter I, because I is for current, letter L. Yung kag L, that is for inductor, inductance, okay? C, capacitor, capacitance, no? So we have this length, no? An area of the core, and then we have also the number. So the number of N is the number of turns, and U is the permeability, no? So ang sa capacitance class, that is permittivity, no? Yung kag permittivity, that is the inherent to the material being used in the capacitor. So there is a inductance or inductor, the the mu class, mu is refers to the permeability of the core materials. So this is the core materials kani. This is the core materials, no? So this is the length, okay? This is the length, okay? The N is the number of turns, and A is the core area, no? So that is the core, okay? Or because inductor using different types of core, no? So napo tay air core, no? Wala siya kuan ba? Wala siya core, but using air as a core. It's just a simple turns of wire like a spring. So there's what we call specific permeability on air using air as a core in an inductor, no? So naa na siya permeability. Okay, so I guess we move to another slide. So inductor in schematic, no? So makakita mo inductor class in schematic, kani ang unit sa inductor, no? Kani ang schematic sa inductor in a circuit diagram. Pwede siyang ingon ani, pwede sad siyang ingon anig forma, no? That is an inductor. And then we have this in terms of relationship current and voltage in an inductor. So let's say we have this inductor. There's what we call we add power supply. There's what we call IT. Okay, IT meaning there is flow of current, no, across the inductor. So what happens then? Of course, when there's flow of current, there's also voltage, no, because it cannot be absent, no. So this is air. So the current, no, adheres to the passive convention, no? So the IV, okay, the IV characteristics. What is IV gani? IV, that is power, no, because P equals to IV, no. Okay, IV there, no, IV, no. The power characteristic of inductor is represented by this equation, no? V equals to L d with the derivative di and dt, no, where L is our Henry, or we can simplify this one simply as V equals to L, okay, I, no, Li di dt, no, di dt, no. That is the derivative of the current with respect to time, no. That is an inductor. And then we have this in a DC state, okay. So make a DC state using DC as our source. A current in the steady state has ongoing persistence behavior. DC steady state means all voltage and currents are constant. So constant siya class. Tanang voltage and current are constant, okay, in a DC state. And inductors behave like short circuit in a DC state. So in a DC state, it behaves like a short circuit. So unsa mo itong short circuit? It's just simply a wire, no? Just simply a wire, no? Connected in. So for example, just simply a wire, no? So wire, no? We assume that wire with no resistance, so that is short circuit, okay? And So this is the DC state, no, that I mentioned kanina, no? And then key concept about inductor, no? In a passive convention, the IB or the power characteristics of an inductor is represented by this formula: V equals to L derivative of di dt. So the current in the inductor is continuous, no? So meaning continuous siya. So the inductor behaves on a short circuit in a DC current, no? So meaning itong kanina, no? And then what happens when we connect series and parallel inductors? Okay? As we know, in the capacitor, it behaves the otherwise of the resistor behavior. So here is different, no? So inductance, we have this formula kanina. Okay? So this is the general formula on how to compute the inductance of an inductor, and the unit is Henry, no? And then what if we connect, no, two conductors, identical conductors in series, no? So is this like in capacitor where we just add the one? No. Okay, so in capacitor, so we cannot add the two capacitors in series, no? We add the inverse, no? But in if they are connected parallel, we can simply add. So what happens in the inductor? Someone is inductor. So it's an inductor class is when you have two inductors connected in series. For example, this is the first inductor and then the second inductor. Just add the two inductor or 2L. Okay. So whatever the unit or the Henry of this first inductor and the second inductor, just add. That is series. Kung imong tan-awon, this is the same characteristics as for the resistor, no? So add ra nimo. So mo na siyang concept. And then uh, so we add that one, okay? So for example, we have this three inductor connected in series, no? And then consider this three inductor in series. It's with positive distributed voltage and inductance. Series element shares the same current. Okay, so the same ni siya sa resistor. The same current naman siya, class. And then actually you can apply KVL, no? So itong KVL, the total voltage across loop is equal to 0. So the V for example here is equal to V1 plus V2 plus V3. Okay, so the voltage drop across L1, L2, and L3 is the total voltage induced in the series connected uh, inductor, no? So kung imong tan-awon dili kay siya problema because it's just the same analysis as what we've done in series. So what if this is in parallel? So since this is connected in parallel, the analysis is still the same as we analyze parallel connected resistor, no? So you can also apply KCL here. For example, in this example, no? Okay, kaning example class, we can apply KCL where the total current across the circuit is the summations of I1 passing through L1, I2 passing through the L2, and I3 passing through L3 or the inductor number 3. So sayon ra gid kay siya, no? Kung inductor, no? Ang inyo lang batayan is ang capacitance or capacitor. Okay, no? So I guess, no? So okay, so kanira man siguro, no? So in the energy reactive elements is to kung as a summary, no, of what we discussed today, ang inductor class, okay, dako kaayo. Ang inductor, this inductor, no, because this is the schematic of an inductor, behaves like of the resistor. So, but in capacitor class, it's the other way around. So, bali ang ato analysis. So, kung makakita kag capacitor nga series, the treatment of that is similar to the parallel inductor or parallel resistor. But when you have capacitors connected in parallel, that is similar to series connected inductor or series connected resistor. So inana siya. Ang inductor gyud bali nga characteristics. Okay? So I guess you have watched this video, no? Because the next slide would be the video that I supposed to share you today, but I've shared this yesterday, no, as reinforced knowledge to what we've discussed this morning about inductor. So far, do you have questions, clarifications?